The sharp, rhythmic crackle of a high-voltage discharge echoes through a damp London night, the sound of ozone ionizing the air. It is 1889 and the Thames is a black ribbon of oil and fog. In a cavernous brick shell in Deptford, a young man with a sharp moustache and eyes that haven't seen sleep in 48 hours stands before a giant copper switch. He pulls it. For a fraction of a second, the darkness of the city is pushed back by a hum so deep it vibrates in the marrow of the onlooker's bones. This is the birth of the modern world, yet if you walk down to Deptford today, near the modern luxury flats of the Stowage, you will find almost nothing. The Cathedral of Power is gone. The man who built it, Sebastian de Ferranti, is a name largely absent from the pantheon of industrial giants, overshadowed by the marketing genius of Edison and the tragic mystique of Tesla. But while Edison wanted to put a small generator on every street corner, Ferranti had a vision of a single, massive heart pumping electricity through the veins of a nation. He was 24 years old when he decided to gamble the future of the British Empire on a voltage that everyone else considered a death sentence. Today we take for granted the silent hum of the grid, the invisible force that powers the screen you are watching. We are told that the War of the Currents was a two-man duel between American titans. This is a convenient lie. The real revolution happened in a gritty corner of southeast London, led by a teenage prodigy who was designing dynamos when his peers were still learning Latin. The paradox of Ferranti's life is that we live inside his invention every single day, yet the physical monuments to his genius, the massive engines, the pioneering cables, the great halls of Deptford, have been systematically erased from the skyline. We remember the light bulb, but we forget the system that makes the bulb shine. To understand Ferranti is to understand why Britain, the workshop of the world, ultimately lost its grip on the very technologies it birthed. In the 1880s, London was a city of soot and flickering gas. Electricity was a luxury toy for the ultra-wealthy, a dangerous novelty that frequently burned down theaters and ballrooms. The prevailing wisdom, championed by Thomas Edison, was low-voltage direct current, DC. It was safe, it was simple, and it was useless for anything more than a few blocks away. To power a city like London with DC, you would have needed a smoky power station every half mile. It was an urban planner's nightmare. Enter the Grosvenor Gallery in Bond Street. In 1883, this high society art hub installed a lighting system that was constantly failing. The wealthy patrons were tired of the lights flickering out mid-soiree. They called in a consultant. They expected an elder statesman of engineering. They got a 19-year-old Ferranti. He didn't just fix the lights. He redesigned the entire plant. At an age when most are just starting their careers, Ferranti was appointed chief engineer of the Grosvenor Gallery Company. He immediately threw out the existing machinery and replaced it with his own patented alternators. The aesthetic of the time was one of heavy, ornate cast iron and polished brass, but Ferranti's designs had a brutalist efficiency that predated the 20th century. He was working with alternating current, AC, at a time when the scientific establishment viewed it with the same suspicion we might view cold fusion today. Lord Kelvin, the titan of British physics, famously stated that AC had no future. Ferranti ignored him. He saw that by stepping up the voltage, he could send power over long distances with minimal loss. By 1887, the Grosvenor Gallery was powering 30,000 lamps across London's West End. But Ferranti knew this was just a pilot program. He envisioned something grander, something terrifying. He proposed building a central station at Deptford, 7 miles from the city center, where coal could be delivered by sea. He wanted to generate electricity at the unheard-of pressure of 10,000 volts. To his contemporaries, this wasn't just ambitious, it was a proposal for a lightning bolt in a bottle that would inevitably explode. The technical hurdles were immense. There were no cables in existence that could carry 10,000 volts without melting or sparking into a lethal arc. There were no engines large enough to drive the dynamos he imagined. Ferranti didn't care. He sat at his drawing board, surrounded by the smell of hot oil and the scratch of his drafting pen, and invented the modern power grid from scratch. He was building the Cathedral of Power, a structure of brick and steel that would house the largest machines ever built by man, all to serve a city that didn't yet realize it was about to change forever. The construction of Deptford was not merely a building project, it was a defiance of the known laws of industrial physics. To house his vision, Ferranti required a structure of unprecedented scale. The site at the Stowage, Deptford, covered 28 acres of riverside land, chosen specifically because it allowed for the direct delivery of 800,000 tons of coal per year by sea, bypassing the expensive rail monopolies of the city center. In 1888, the Cathedral of Power began to rise, a massive brick edifice with walls 5 feet thick at the base, designed to withstand the vibrations of engines that had yet to be built. While his competitors were thinking in terms of hundreds of horsepower, Ferranti was drafting plans for 2 initial 1,500 horsepower engines, with the ultimate goal of installing 4 10,000 horsepower giants. To put that in perspective, the largest marine engines of the day, those powering the great transatlantic liners, rarely exceeded 5,000 horsepower. The most immediate technical wall Ferranti hit was the transmission. No manufacturer in the world could supply a cable capable of carrying 10,000 volts. The rubber and gutta percha insulation of the Victorian era would have disintegrated or burst into flames under such pressure. Ferranti's solution was as brilliant as it was deceptively simple. He invented the concentric paper-insulated cable. These weren't flexible wires, they were rigid 20-foot rods consisting of 2 copper tubes separated by 1/2 inch of brown paper, meticulously soaked in a mixture of ozokerite wax and resin. Every single joint, and there were thousands over the 7-mile stretch to London, had to be hand-tapered and sleeve-joined by specialized workmen. This was the Ferranti main, the ancestor of every high-voltage underground line on the planet. He established a factory on site at Deptford just to manufacture these, costing the London Electric Supply Corporation, LESCO, over £100,000, a staggering sum in 1889. The machines themselves were monsters of iron and copper. The 1,500 horsepower engines, built by Hick, Hargreaves and Company of Bolton, drove dynamos with flywheels 45 feet in diameter, weighing 460 tons each. The sound in the turbine hall was described by contemporary visitors as a continuous, world-shaking roar that made speech impossible. Ferranti was obsessed with efficiency. He designed his own transformers, his own meters, and even his own switchgear. At a time when high-voltage switching often involved a brave technician pulling a lever and hoping the resulting 3-foot arc of blue flame didn't kill him, Ferranti was developing oil brake switches and safety interlocks that were decades ahead of their time. But the struggle wasn't just against physics, it was against the law and the lobbyists. Thomas Edison's UK representatives and the established gas companies were terrified of the Deptford scheme. They lobbied the Board of Trade, sparking the famous 1889 inquiry led by Major Marindin. The critics argued that 10,000 volts was a public menace. They called it the executioner's current. The 1882 Electric Lighting Act had already crippled the industry by limiting company franchises to just 21 years, after which local authorities could buy the infrastructure at scrap value. This made long-term investment almost impossible. Ferranti had to fight through weeks of testimony, explaining to skeptical bureaucrats why his high-pressure system was actually safer than a dozen small, low-voltage stations scattered through the slums. He famously demonstrated the safety of his cables by having an assistant stand on a grounded metal plate while a colleague drove a cold chisel through a live 10,000-volt main with a sledgehammer. The fuse blew instantly and the assistant remained unharmed. It was a piece of theatrical engineering that stunned the committee. Despite the bravado, the financial pressure was immense. LESCO had poured over £800,000 into Deptford, roughly £110 million in today's money, before a single watt of power was sold from the new station. Ferranti was working 18-hour days, often sleeping on a cot in the engine room. He was the chief engineer, the architect, the primary inventor, and the public face of the project, all while still in his mid-20s. The war of the currents in Britain wasn't a battle of marketing, it was a battle of sheer industrial will against a backdrop of deep-seated Victorian conservatism. The zenith of the electric king. By the autumn of 1890, the impossible had become a vibrating, hum-inducing reality. Sebastian de Ferranti stood in the control room at Deptford, surrounded by polished slate panels and brass gauges, watching the needles climb. The first 10,000-volt current was surging through the paper-insulated mains, traveling 7 miles beneath the streets of London to the transformation substations at the Grosvenor Gallery and Trafalgar Square. It was a triumph that defied every established law of the Victorian Engineering Guild. For a brief shining moment, Ferranti was the undisputed master of lightning. The station was a marvel of the age, attracting the kind of attention usually reserved for royal weddings or new colonies. The Prince of Wales, the future King Edward VII, visited the site, standing in awe beneath the towering flywheels of the Higg-Hargreaves engines. He reportedly asked the young Ferranti if the massive voltages were truly safe. Ferranti, with his characteristic calm, explained that the danger was precisely what made the efficiency possible. The scale of the operation was gargantuan. At its peak during this period, Deptford was designed to house the Big Four colossal 10,000 horsepower generating units. To visualize this, each rotor was 45 feet in diameter, weighing 225 tons, and stood as high as a 4-story house. These were not just machines, they were the largest moving objects ever created by human hands at that time. The cost for these 4 engines alone was estimated at £250,000, nearly £35 million today. Ferranti's vision was total. He wasn't just selling light, he was selling the future of motive power. He predicted that one day every factory, every sewing machine and every cooking stove in the British Isles would be fed by the singular heartbeat of a few massive rural stations. He was describing the national grid 60 years before it officially existed. The social spark and the engineering anecdotes. The Deptford scheme became the talk of London's elite. In the smoking rooms of Pall Mall, members of the Royal Society debated whether Ferranti was a genius or a madman. There is a legendary story of a high society dinner where a skeptic challenged Ferranti, claiming that his high-tension cables were a ticking bomb beneath the feet of Londoners. Ferranti allegedly reached into his pocket, pulled out a piece of his concentric cable and handed it to the man, saying, "The only thing dangerous about this cable, sir, is the ignorance of those who fear it." However, the aesthetic of this success was deceptive. Behind the scenes, the London Electric Supply Corporation, LESCO, was bleeding capital. The sheer ambition of building everything from scratch, the cables, the dynamos, the very bricks, meant that dividends were non-existent. Ferranti was a perfectionist in a world that demanded immediate returns. He would often order entire sections of machinery to be dismantled and redesigned overnight if he found a flaw of even a fraction of a percent in efficiency. This obsessive drive for excellence began to grate on the board of directors, specifically the Earl of Crawford, who had once been Ferranti's greatest champion. The crack in the porcelain. The turning point came on November 15, 1890. A fire broke out at the Grosvenor Gallery substation. It wasn't a failure of Ferranti's 10,000-volt mains, but rather a fault in the older, lower-voltage distribution equipment. However, the optics were disastrous. Much of the West End was plunged into darkness for weeks. The newspapers, many of them influenced by the competing gas companies and the low-voltage lobby, pounced. They painted Deptford as an unstable monster that could fail at any moment. In 1891, the internal pressure reached a breaking point. The board, terrified by the mounting costs and the technical setbacks of the massive 10,000 horsepower engines, which were proving difficult to stabilize, made a fateful decision. They demanded that Ferranti scale back his vision. They wanted smaller, safer, more conventional units. Ferranti refused to compromise. In a move that mirrors the modern boardroom ousters of visionary tech founders, the board of LESCO dismissed Sebastian de Ferranti from his position as chief engineer. He was 27 years old. He walked out of the Cathedral of Power he had designed from the first brick, leaving his giant engines half-finished. Magnificent, silent skeletons of a future that the moneymen were too afraid to inhabit. This moment in 1891 marks the beginning of a recurring British tragedy, the pioneer's penalty. Much like the later developments in computing with Alan Turing or the jet engine with Frank Whittle, Britain had birthed a world-changing technology only to let it wither through a lack of nerve and a surplus of bureaucracy. The market pivoted towards safe bets, smaller, inefficient local stations that cluttered the city, exactly as Ferranti had warned. Today, as we struggle to transition our entire energy grid to renewables, we face the same same tension Ferranti did, the conflict between the radical, large-scale shifts required by physics and the cautious, short-term quarterly demands of the financial sector. We are still living in the shadow of the 1891 boardroom decision, oscillating between the need for bold, centralized innovation and the fear of the lightning it requires, the exile to the north and the long vindication. After the doors of Deptford were shuttered to him in 1891, Sebastian de Ferranti did not fade into the gentle obscurity of a retired academic. He was a man possessed by the physics of the future. He moved his operations north to Hollingwood, near Manchester, founding Ferranti Limited. It was a strategic retreat. In the north, the air was thick with the coal smoke of 1,000 factories that actually understood the value of power. He pivoted from being the architect of the grid to being its master smith, manufacturing the high-precision meters, transformers and switchgear that would eventually populate every substation in the British Empire. By 1905, Ferranti Limited was the premier name in electrical measurement, a irony not lost on Sebastian. He had been prevented from building the heart of the system, so he built its nervous system instead. While Ferranti thrived in Manchester, the Cathedral of Power at Deptford underwent a slow, agonizing transformation. The board of Lesko, having purged their visionary, realized too late that the world was moving exactly where Ferranti had predicted. By the early 1900s, the low-voltage advocates had been soundly defeated by the cold mathematics of transmission loss. Deptford was upgraded, expanded and eventually split into Deptford East and Deptford West. The original 1889 station, the one built with the 5-foot-thick walls and the revolutionary paper cables, remained the spiritual core of the site. It continued to pump power into London through 2 world wars, its chimneys becoming blackened sentinels on the Thames, surviving the Blitz while neighboring docks were turned to rubble. The echo in the modern grid. The ultimate irony of Ferranti's life arrived in 1926 with the Electricity Supply Act. The British government finally did what Ferranti had begged for in 1887. They created the Central Electricity Board to build a national grid. The 132,000-volt lines that began to march across the British countryside were the direct descendants of the 10,000-volt Ferranti mains. Sebastian lived just long enough to see his central station philosophy become the law of the land. He died in 1930, having received the Faraday Medal and served as president of the Institution of Electrical Engineers, finally recognized by the establishment that had once treated him as a dangerous radical. But as the man was canonized, the industry he birthed began a long, slow decline into the shadows of the 20th century. Deptford East, the pioneer, was finally decommissioned in 1957. Its more modern sibling, Deptford West, survived until 1983. When the switches were finally thrown for the last time, the silence that fell over the stowage was absolute. For nearly a century, that patch of mud by the Thames had been the loudest, most electrically charged spot on the planet. Today, if you visit the site at SE8, you will find Ferranti Park and a series of luxury apartment blocks with names like the River's Edge. There is a small weathered plaque near the Thames path, often obscured by shadows or graffiti, marking the spot where the modern world began. The massive brick halls were demolished in the early 1990s, the colossal iron engines sold for scrap or melted down to make the very cars that now drive over the site. The Mirror of the Pioneer. The story of Sebastian de Ferranti is not just a chronicle of cables and coal, it is a mirror held up to the way we treat the architects of our reality. We live in an era of disruption, yet we often forget that the most profound disruptions were fought for in the mud of Victorian London by 24-year-olds who risked their reputations on the strength of brown paper and resin. Ferranti was overlooked not because he failed, but because his success was so total that it became invisible. We don't notice the air we breathe, and we don't notice the grid that sustains our digital existence. Britain's industrial history is littered with these ghosts, men and women who built the foundation but were denied a seat at the feast. We see this pattern repeating today in the fields of fusion, quantum computing and green hydrogen. The visionary proposes the impossible, the financial world recoils in fear, the visionary is ousted, and 30 years later the world quietly adopts the impossible as the new standard. Sebastian de Ferranti's legacy is the silent hum in your walls, the glow of your smartphone, and the stubborn fact that even when the cathedrals are torn down, the light they created remains. In the end, the man who tamed lightning was buried in a quiet family vault, while the city he illuminated moved on without a backward glance at the riverbank where it all started. The greatest monument to a genius is the world that no longer remembers why it needed him.